Alrighty, it is 20 past 10 on what apparently you all call a cold winter's day. I have no idea what is wrong with you people. This is summer for me. Although I was told that if I presented in shorts, everyone would look at me stranger than they normally do because of these shirts. Thank you all for coming. My name is Barry Dorrans. I am the security PM for .NET, which is a generally very unhappy job. This is my fun presentation. If you want actual technical content, that's going to be on Friday. So as the security PM, it basically means I get to lecture everybody in .NET, try and tell them how to do things properly, hope that they do things properly, and then I have the unfortunate role of trying to deal with things when everything goes wrong, when security bugs are reported to us. If you want to follow me on Twitter, I am @blowdart. There is even less technical content on my Twitter feed than I do in this presentation, so just be warned. You can see a complete rant about Australia when I was jet lagged on Thursday, which apparently some people find very funny. So today I am going to go through 4 MSRC bulletins. MSRC is the Microsoft Security Research Center, and the code mistakes that caused them. And then I'm going to talk about a few things that we have caught in various pieces of .NET or in code that uses .NET before they created an MSRC, so the rare occasions I actually did my job right. And these are going to be things that you may indeed be doing in your own software right now. And then I'm going to follow up with a couple of scary demos that our lawyers say I have to warn you about now, so if you are a nervous disposition, you should leave. I will warn you again before it happens. So, it takes a long time for us to produce patches, as I'm sure some of you are aware, and you may be asking yourself, why does it take such a long time to produce patches? Sometimes it's because I'm spending a week in Australia, and I'm just not answering emails. But generally what happens is someone will report a vulnerability to secure@microsoft.com. An MSRC open a case in their security database, which is in Dynamics. Anyone that has used Dynamics will realize that this is completely horrible, and that does slow things down because the UI is awful, but never mind. I get an email from the product group security rep in MSRC, and they email the product group security rep for .NET, which is me, and only me, which is why me doing conferences does delay things. And so what I do is I look at the vulnerability, I look at the description. Hopefully the finder has produced some code that I can use to reproduce the problem. Otherwise, I have to try and remember to code again, because when I moved from being a developer to a PM, they basically cut the developer parts out of my brain. The scars have healed, though, so it's fine. So I attempt to reproduce it, and when it reproduces, I swear loudly, I panic, and then I go find the guilty developer and stand over them and go, what have you done? So they then try to reproduce it, and then comes the first part of the lag. We have to reproduce it against every single supported operating system and software version of .NET. Now, when I say every single operating system, I don't just mean Windows 7, Windows 8, Windows 8.1, Windows 10, and Server. No, I mean in every single language that we support. And again, we have to try it against every single version of .NET on those languages. So as you can imagine, the test matrix for this is huge. I have a desktop that runs about 64 VMs, and that is not enough. So I have a bunch of VM servers sitting there that have, you know, Australian English versus US English, because sometimes that does make a difference. So that reproduction can take, honestly, a week. Then the fix is developed, and that's the quick part. Developing the fix maybe takes a day to a week, depending on how complicated it is. And then we go away and we look for variants of the same thing, and that may add another week. So 2 weeks to develop the fix, and we test it. We honestly do test. I know that some of the quality of the things that come out over Windows Update might indicate that we don't. But it is tested. Then I spend a day trying to write instructions on how to update things, which is easy for .NET Framework and really stupidly complicated for .NET Core. We then deploy the fix internally to selected machines within the Redmond domain. probably about 90% of workstations in the Redmond domain will get forcibly rebooted about 3 weeks before Patch Tuesday, just to make sure that nothing breaks. And at the same time, we will give the patch externally to 2 or 3 victims, or as they like to see themselves, trusted partners, to see whether we will break their stuff as well. And then finally, on Patch Tuesday, a button is pressed and everything magically goes live because we had uploaded it the week before. So that's why it takes about 6 months. I am going to go through 4 security bulletins, only one of which I am responsible for. The rest were before I joined the team, although I'm not convinced I would have caught them either. So the first one we have is a glorious denial of service attack through our hashing functions and dictionaries, which was in 2011. And this was hilarious. This one got Scott Guthrie involved, which is never good. It is caused by the way we calculated hashes in the .NET dictionary classes. And so when you send a form post or a simple GET request to ASP.NET, we will split things apart. We will take the form input and we will use the title, and that will go into a hash table. We will use the title of parameters and it will go into a hash table. And the problem was that the hashing function that we used was easily calculated, so you could do hash collisions. Now, I'm sure some of you have gone into job interviews and have been asked to write a hash table from scratch, at which point I generally walk out of the job interviews, because if you're not going to use the ones that are in the library, seriously, what is the point? So for those of you that haven't, I'm going to try and explain this using cats. Now, I make this perfectly clear that I'm a dog person. How many people here are cat people? You are wrong. So when you go on holiday, you cannot leave your cat in the house alone because cats are evil and they will destroy everything. So you take your cat to a cat vacation home. And you go to the vacation home and go, here is my cat. Please store my cat for the week that I'm away, and I will come back in a week and I will get my cat back, and hopefully it will be the same cat. So there has to be a way of classifying and labeling the cats so you can make sure that you get the right one back again. So I'm going to give a simple example where the cat holiday home has 26 rooms. And if your cat's name is A, it will go into the room labeled A. If your cat's name begins with B, it will go into the room labeled B, and so on and so forth. We are taking the name of the cat and we are hashing it to a common value so we know roughly where in the home or in the hash table our cat is located. So when we come back, we can get it quicker, rather than just shoving everything in one room and having to go through every single cat when I want to try and find a cat named Alan. Does that make sense? Yep, okay, we're good with that so far? This is then where I show my disgust with cats. So an attacker comes along, and he has 756 cats in a bag, and he says they're all named Alan. And now you have a problem, because your hashing function goes, okay, well, I'm going to take Alan, and he's going to be reduced to A, and I need to put him in the A room. So in the A room, you shove 726 cats, and you are scratched, and you are bitten, and the room is very full, and you have to push a tail in before you can close the door. So this causes problems, because it takes a long time to shove all those cats into the A room, and this illustrates our denial of service attack, because a hash collision spikes CPU. So you can think of the amount of time shoving your cats in as being equivalent to CPU time. And then when the attacker comes back and says, hi, I'd like Alan out, you have to go back into the A room, which has 726 unhappy cats, hissing and spitting and scratching, and you have to pick up each one and take it back and go, is this Alan? No, okay, put it back. Pick up the next one. And if you're unlucky, you'll get it right the first time. If you're unlucky, you're going to have to go through all 726 cats. Again, spikes in CPU. So I can demonstrate this. Oh, here is a link, well, a description of the original paper, which was from the Chaos Communication Congress, which is a horrible hackers conference that takes place over Christmas with no respect for anyone's holiday. So when things happen at that conference, I generally get a phone call when I am trying to stay upright on the ski slopes, because I am not a very good skier, but I still try because the wife likes it. So yes, I've had to come down off the ski slopes for things from this conference. Originally, it talked about PHP. Security vulnerabilities in PHP should not be a shock to anyone. Java, Python, and JavaScript. The same for JavaScript. Security problems in JavaScript should be well known by now. And then someone decided that wasn't enough, and they decided they wanted to make me unhappy, and they ported it to C# and ASP.NET. This is why I chain smoke, because I want my pain to end. So I'm going to demo this. You will see my wonderful UI skills with each of these demos. So let's switch to the HashDOS one. And we will start it, and I'll show what we're doing here. We are taking a string, and we are going to shove it into a dictionary, which is a hash table. And then we are taking another string, and we're going to shove it in. But the other string is really stupid. How many of you override GetHashcode in some of your classes? Yeah, I'm about to make you really unhappy. So GetHashcode here returns a fixed value, because this is the dumbest string ever. So if I run my little demo, and we can see my wonderful UI skills. So as I was talking, it had gone through putting the million strings into the hash table, and it took that long. And now, instead of putting a string in, we are going to put our bad string in. And if I leave this running, this will run throughout the entirety of this talk and beyond. I used to present from a Surface Pro 3, and I could put my hand there, and I could feel everything get warm, and you could hear the fan come on every time I did this. So we fixed this eventually. And what we did is we now use a randomized hash code for a string. When a process starts up, we will set a random value just for that process, and we will merge it into the hash for the string. So you cannot pre-compute, because that seeding key is going to be random each time. I guarantee none of you who put your hands up saying, yes, I override GetHashcode are doing this. Are you? Anyone want to say that they are? Oh, good, none of you are going to lie. OK, so if you have overridden GetHashcode and you are constructing these classes solely from user input, and you're shoving them in a dictionary, you have a problem, and you need to do this randomization. If you're constructing them but not taking them from user input, it doesn't matter so much. So the hashing algorithm that you should use is probably an authenticated MAC. SHA-1 is the one that we use. It doesn't have to be particularly secure. You don't have to go to SHA-256 or SHA-512, just as long as there's enough randomization there that an attacker cannot pre-compute. So that is MSRC case number 1, which was glorious. Number 2 is a padding oracle attack. Let me start off by saying encryption is hard. We have crypto people. We have an entire crypto board, including people that write the own algorithms for fun, and then get them approved for use by pushing them out through the cryptographic community. And frankly, my meetings with those guys are never pleasant, because they will sit and they will pick holes in every implementation or how we want to use things, and then I have to go away and redo stuff, and then come back a week later and they pick more holes, and so on and so forth. The only time it's fun is when I'm sitting there, but I'm not the one with the use, and I'm just sitting there in the audience going, that could be me. So a padding oracle attack. We're not talking about the database here. An oracle is something that gives information away in a cryptic form, like the oracles at Delphi, like ministers and priests, anyone that wants to speak on behalf of a higher power. You will notice that the answers that they give never really are straightforward. So a padding oracle in this case gave away information that the padding on an encrypted string was wrong. So I should explain what padding is. A lot of encryption algorithms are block algorithms, and what they do is they split things into blocks. And so it takes the first block of data, encrypts that, and then feeds the results into the second block, and then the third block, and it goes like a little sine wave. And the blocks have to all be of even size. So if they're not the right size, there is always padding at the end. And so what an encryption algorithm, when it tries to decrypt first, is it looks for padding at the end. And if the padding is wrong, it stops. And that operation is really, really quick in terms of time. So you can detect that there is invalid padding just by watching how quickly you get an error back. And because you can detect this, what you can do is you can use this speedy return to start trying to craft strings that will eventually be decrypted properly. And so you take that padding byte at the end and you tweak each individual bit, and until you get, nope, the timing's slightly different, so that byte must be right. And what someone did was they used this capability and they fed it into a file called scriptresource.axd, which was part of web forms. How many of you are still using web forms? How many of you are still using web forms who are not in government, banking, or health? Yeah, okay. I am so sorry, by the way. Really, just try and force them to move with the times. So scriptresource.axd was supposed to be an ASP.NET handler that would allow you to serve JavaScript out of DLLs where they were embedded as resources. Fortunately, it was a bit stupid, and it would allow you to serve any file whatsoever, which didn't seem that bad because we were encrypting the parameter that was sent to it using the machine key that's in your web.config and a bunch of other stuff. Unfortunately, it was just encrypting. The right way to do encryption is you encrypt and then you sign. And you sign with an authenticated mechanism, that SHA-1 HMAC that I talked about slightly earlier. But we were not doing that. So we exposed the oracle because we had no signature, and we just took what we were given and shoved it straight into the decryption methods. If we had had a signature, the first thing you do is you check the signature, and you compute what has been sent to you, and if the signature does not match, someone's tried to change it, and you just reject it entirely. And then you don't have a padding oracle attack. So what this guy did was he attacked scriptresource.axd, and he managed to get it so he could have the file path encrypted correctly for web.config. And so scriptresource.axd, because of this padding oracle, he could script the encrypted string for web.config without knowing the encryption keys, just detecting this slight change and the change in speed. And then he feeds that in scriptresource.axd, and lo and behold, it served up your web.config file. So that means all your connection strings that are in there, including your usernames and passwords, are now exposed to the internet. And if that wasn't bad enough, if you have set a machine key, well, the machine key was used to encrypt not just the scriptresource.axd stuff, but it was used to encrypt view state, and we'll talk about why that's bad in a minute. But it's also used to provide the protections for cookie authentication. So once I've got your machine key, I can pretend to be whoever I like in your application because I can craft a valid authentication cookie for that user because I know what key is being used. This is a bit of a big deal. So we fixed it by finally doing the right thing and shoving a signature on the end of the parameter that goes to scriptresource.axd. And we fixed it so it would only ever serve up JavaScript and no more web.config, just in case we messed up the first half of the fix. So this was originally presented as an attack on SSL, which is great. And then someone made me really unhappy and expanded it out to ASP.NET, and you can go and look at their presentations and the papers and the very heavy mathematics behind this thing. So the way to fix this is you just don't expose any of these padding oracles, and you add signatures to all of your encrypted data. And I will keep saying this again and again. When you are encrypting, encrypting is not enough. You need to add an authenticated signature to your data. SharePoint. SharePoint is the bane of my security life because they base themselves on ASP.NET, and when they do something dumb, they blame us. This was the dumbest thing I have ever seen. I love it when the SharePoint people watch recordings of these presentations because I get emails. So this was remote code execution via serialization. Those of you that are still on web forms and those of you that have used web forms in the past will be aware that there is an enormous hidden input field inside every single web forms page called viewState. And what viewState is binary data that has been pushed through binary formatter or other types of serializations and formatters that hold state for a bunch of other things. When we read the page, we deserialize that, and we can't restrict it to individual objects because we don't know what you've put in there. So we deserialize it and say, OK, tell us what you are. We'll create that object for you, and then we'll populate all the properties that you need to have. That was an incredibly stupid idea, to be perfectly honest. However, we protected it by signing viewState with a viewState MAC. SharePoint, in their infinite wisdom, decided they did not want the performance hit of having viewState MACs turned on, and they didn't want to have the complications of setting keys in web.config, so they turned it off. And I can demonstrate what happens when you turn this off. So let's see. ViewState. So the .NET framework has a bunch of classes that are marked serializable that frankly should not have been. And one of my favorite ones is temp file collection, which hides away inside code DOM. And what temp file collection is used for is when code DOM is compiling code, it creates a bunch of temporary files in your temp directory, then spawns off the compiler rather than doing everything in memory, but that's what we have Roslyn for now. And then it cleans itself up. So it's a way of tracking all the temporary files that it has created. And the way it does that is there is a property for all the temporary files, and when that object gets disposed, it goes and deletes all the temporary files, which is great. Until you say that one of my temporary file names is web.config. And so what happens is eventually, when this object exists with web.config in its temporary file name, and the garbage collector gets to it, it deletes web.config, and your SharePoint site goes down. Which, let's be honest, is a blessing, because it's SharePoint. So here's what we're going to do. I'm going to create a temp file collection. I'm going to add web.config to it. And then I'm going to just serialize that temp file collection, and then I'm going to bring it back in again. And read viewState just does a straightforward binary formatter deserialization. And then I'm going to force garbage collection, which of course you never do in your own code. But no one wants to wait 20 to 25 minutes for this thing to actually work. So let me bring up Explorer. And you will see that there are 3 files in here. And I'm going to hit Start. And it's going to create a temporary web.config, which is here. And here is my viewState. And I'm going to do what viewState does. I'm going to read it in, deserialize stuff, and then I'm going to force garbage collection. And lo and behold, my web.config has vanished, as is my attack file, because I like to clean up after myself. And your SharePoint site goes down. So we fixed this by introducing the first ever breaking change in ASP.NET for security, which made me very happy. When you try and tell ASP.NET now that no, you don't want viewState MAC on your viewState, we ignore you. It's always going to be there whether you like it or not. So when SharePoint turns it off, doesn't matter. It has no effect. So we will have this signature. So we will know that the data that has been put into viewState and round-tripped to the user and has come back again has not been tampered with. So when you round-trip stuff to a user, you need to sign it. And you need to sign it with an authenticated signature, because otherwise someone can just compute a straightforward MD5, append it on the end, and it doesn't matter. It has to be authenticated. You have to have a private key that feeds into your authentication mechanism. The other interesting thing to note is you should not publish your signing key. I love GitHub so much because I can search for web.config and look for machine keys that are fixed in web.config. After the view state stuff came up, someone expanded this to point out that it didn't really matter if we turned everything on by default if you have published your signing key. So lots and lots of software delivered themselves with web.config with fixed machine keys. So everyone's machine key, no matter who they were, for this individual piece of software was the same. So we had 6 months of going around and telling people this was an incredibly bad idea and they needed to remove it, and we would demonstrate what the problem was and bring their websites down, and then they go, oops, and they'd have to redo everything and reissue stuff, and it was a lovely cascading set of security bulletins from various other manufacturers. It's nice when I can share the pain, to be honest. Regular expressions. This one I was responsible for, or at least for not catching. How many of you use regular expressions in your everyday code? You are bad, bad people. How many of you use regular expressions to validate user input? You are even worse people. I despise regular expressions. When we redid everything for .NET Core, I went on a crusade against regular expressions and got every single one removed except for the one in routing where you can set a regular expression for matching routing because we didn't want to drop the feature. Simple regular expressions are fine. Well, they're not fine because they're still really hard to read and understand. But complicated regular expressions that go backwards and forwards and backtrack and forward track, they are basically a program. And with certain types of regular expressions, you can send that program into an infinite loop. And that's not something you want to happen when you're validating data. So you can guess what happened here. We will skip across to regular expressions. Here we have an email address. And I'm going to split it into a regular expression that someone thought was a good idea to put in our data validation classes. We should probably look at the regular expression. Would anyone who said that they were using regular expressions for validating user input care to explain what this does? Let me keep going. No. Still. Well, yeah, okay. That's longer than the break between England winning the Ashes each time. So this is a bad regular expression. If any of you have written something like this, you need to be ashamed of yourself. So what I am going to do is I'm going to put a valid email in, and then I'm going to put in an invalid email. And you can guess where this is going by now. Testing against the good value, testing against the bad value. Again, like the hash code, this will pretty much run for the entirety of the presentation, but unlike the hash code, which would eventually end, this will not, because I have sent the regular expression into an infinite loop. This is why regular expressions are bad, because it is incredibly easy to write a regular expression that can do this, but really, really hard to spot. At least that's my excuse for not spotting it. So this was reported to us by someone that worked for NATO, which is really embarrassing. When you get an email from NATO, I think it's nato.eu, and you're like, and it starts with security vulnerability. I'm like, uh-oh. So that's not good. So there are ways to fix this. Find something other than regular expressions to validate your input. Yes, it may take more code, but I guarantee you it will be more readable than something like that monstrosity. If you feel you have to use regular expressions because you're the only person in your company that understands them and it gives you job security, which is the only reason for using them, you should set a timeout on your regular expressions. Now, .NET is dumb. It does not set a timeout by default, and I cannot change that because of backwards compatibility. Because every time I try and improve something that breaks backwards compatibility, I guarantee you that a large customer will shout at me, and then management gets very upset. I upset management enough without having customers do it as well. So you should go through all your regular expressions and make sure there is a timeout. That is work for all of you that raised your hand earlier. There is a shortcut if you are using the .NET framework, not .NET Core, but if you're using the .NET framework, you can set a default timeout for all your regular expressions by using an app domain setting up there. This does not exist in .NET Core because we don't have app domains, because they were silly. But you can set that. The problem being, of course, that some of your regular expressions may need to run slightly longer than others, so you're going to have to go through and fix those. And if you're going through and fixing those, you should just set a timeout for each individual one anyway. So we're going to move on to mistakes that we have seen. Putting user input into HTML is easy. We all know that we should call HTML in code, right? Anyone want to admit to not calling HTML in code ever? If you do want to admit to that, could I have your website address as well? The problem comes when you want to put user input into JavaScript into an HTML page. So this looks like it's doing the right thing because we are calling HTML in code. But on mouse out, the pieces between the quotes and on mouse out is JavaScript. So I'm HTML encoding, but I should be JavaScript encoding. And we can't detect when you're inside JavaScript, not even in Razor. So really that should be JavaScript encoded. And then it should be HTML encoded because you're putting it into an HTML page. And if you get the order wrong, well, then the encoding can fail miserably, and you either get JavaScript errors, or worse, you get XSS because you haven't got them in the right order. So encoding is context-specific. You have to use the right encoding method depending on when you are putting data in. So if you want to take user input and put it into JavaScript, do this instead. Have a div tag, have a bunch of data parameters on it, and shove the value into the data parameter. Now, admittedly, this gives you a little more work because you have to write some JavaScript to pull that out before you can then use it elsewhere. But this is the safe way to do it. URL abuse. I like this one. So I call this REST abuse because I like annoying everyone that gets religious about what REST is. And that's a lot of people. But you can imagine that you have a site that has a user administration page, and because you're trying to have pretty URLs and be restified, you can hit a delete URL, which is great, and you construct the delete URL like that. So if I create a username with /admin, what happens is when the browser gets that URL, it knows there's a / and it knows it has to navigate up. So it removes it before it sends it down. So now I'm ending up actually deleting my admin user, which is nice. If you're constructing URLs from user input, only do it for the Roman character set. Anything that is going to be fancy, anything that has weird characters or exclamation marks or any sort of punctuation or accented letters or Russian or Japanese or whatever, stick it in the query string. I know people like having fancy URLs, but fancy URLs are sometimes not safe. Anyone Turkish in the room? I've had someone say yes to this once. So, what would we like to guess that little snippet of code does? There are only two answers, so come on, someone can shout out something. You're not European. Europeans do not interact, especially Scandinavians, in presentations. Someone shout out true or false. False in Turkey. Well done, because I mentioned Turkey. And what then is it in Australia? True. Well, it's true, but it's upside down. Okay, so people make security decisions based on string comparisons, and let's prove this. You see, Turkey is a very strange language. It has multiple ways of doing an uppercase. Will you stop? There we go. Look, denial of service attack on myself. Globalization, here we go. Set a startup code. So I'm just going to do a compare, and then I'm going to switch to Turkish. And as you can imagine, because all my demos end up doing the right thing first and then showing something that goes horribly wrong, they're equal, and then they're not. Because Turkey has 3 different ways of uppercasing the I, which has actually caused murders. Not kidding. The person that actually said, yes, I am Turkish, then went on to describe this to me, where there are certain words in Turkish where the change of the capital letter I changes from a compliment to an insult. And someone had texted his girlfriend's brother to say something nice about his sister, and it used the wrong I. And the brother seriously got upset and stabbed the sender. So, yeah, globalization is complicated, and you're going to get stabbed. So when you're doing string comparisons, always compare using ordinal ignore case, because that will get away from all the globalization, and just use very simple uppercase things. So, you know, interesting and interesting would be equal. How many of you turn on your code analysis rules in Visual Studio? Pretty sure at least 50% of the people that raised their hands are lying, because my God, they're annoying. I know that people turn them off because they're very annoying, but there is a specific code analysis rule for this. So I would suggest to you that you turn on CA 1309, recompile absolutely everything, and then put your head in your hands, because you've done lots of string comparisons that aren't using ordinal ignore case. And then go and fix them once you stop sobbing. Unicode. I had this one emailed to me from one of our developers in Microsoft IT. Unicode has this weird thing called full width characters, or as I like to call them, American characters, because now that I live there, I'm getting a lot more full width. So I know it's a little bit hard to see, but on the left-hand side, we have a normal less than, and on the right-hand side, we have a full width less than that is bigger and wider. That actually is 2 Unicode code points, because you don't have characters in Unicode, you have code points. Browsers will ignore it, so this script, which is written in full width, will not execute as JavaScript. However, what our IT people were doing was they were storing this input in a varchar field in SQL. Not an nvarchar field like anyone sensible, but a varchar field. And SQL, rather than say, I'm going to lose some information here and stop, it decides to be really helpful, and it took those wide characters and switched them to their skinny characters. So someone could do a wide character script, SQL would convert it, you would now have persisted XSS within your database. So don't use Unicode columns or non-Unicode columns to store Unicode characters. And don't trust anything that comes from a database. Look, I know you may feel that the database is underneath your, or is under your control. You still shouldn't trust it, because it may not be. Someone could have inserted things into your database that you are not expecting it to be there. Crypto mistakes. This is from an email that I was sent, which now everyone does because they think it's funny, because I got absolutely furious. I get furious a lot. This was from a PM on an Azure product team who will rename, the team will remain nameless, only because their developers followed up 3 seconds later and went, no, that's not right. This is how we encrypt it. So people make mistakes between encoding and encryption. People also do this. That, interestingly enough, was the same Azure team about 6 months later in a different developer. That product was fun. People reuse their keys far too often, and they reuse their initialization vectors. So you know I was talking about how blocks work with the little sine wave. We take the first, we split everything into little blocks. We take the result of the first encryption of the block and feed it into the second one, which is then a seed, and that waves like that. But there's kind of something missing is what feeds into the first block, because there's nothing before that. And what feeds into the first block is called an IV, or initialization vector. And it is a bunch of cryptographically secure random data, which means don't use the random class. Use the ones in system.cryptography. But people reuse this. You shouldn't reuse it. It needs to be unique for every single value that you are encrypting. In much the same way, like if you are hashing, you need to use a unique salt each time. So people reuse their IVs, and that's a huge no-no. And people reuse their keys for different things. It's like, well, I have one master encryption key. I don't want to manage having 37, so I'm just going to use the same key for absolutely everything, which is also a bad idea. What we do in ASP.NET is we have a master key, and then we have this thing called purposes. So going back to web forms, we used the key in web.config for signing your authentication cookie and for signing view state. But what we did was we took our master key, and then we added a purpose to it, and we derived a key from the master key and the purpose. So the keys would actually be different depending on what they were going to be used for. So don't reuse keys. And like I've said, encrypted data needs to be signed with a message authentication checksum. If you are going to concatenate strings and encrypt them, stick the length in, because otherwise, well, built-in and securely is equal to built insecurely. If you concatenate the two together, you're never going to be able to tell the difference. So if you're concatenating, put the length in. And if you are validating signatures, never validate by hostname alone. We all have cert pinning in our browsers now, even in Edge, and I believe in IE. You should be looking at the issuer of the certificate, and in the sample code for this, I have a little console app that will take a certificate and calculate the SPKI, which is what generally people pin on, so you can see the code to do this in your own code. Hash comparisons should be time consistent, so when you are comparing things that are hashed, you don't want to exit early just because something doesn't match, because now we're getting into timing oracles. Not just padding oracles, there are timing oracles. So that is a correct way to do hash comparisons. Honestly, you don't need to take photographs of all of this. The presentation will be on my website in about 30 minutes if I can get the darn Wi-Fi to work, which is really hard here. Mass assignment, MVC and WebApi use binders, and binders take the input that is coming in a request and bind it to an individual object. For heaven's sake, use view models. Because if there is a property that which is on your class, and entity framework classes are great for this, even though there's not an input field on your HTML page, if I know what that property is, and ID is usually a good one, or owner, I can just insert a hidden form field of ID or owner, and the binder for MVC will bind to it, even though you've not got it as a displayed input form. So you use view models, use something like AutoMapper to copy your properties over between your view models and your actual entities. If you don't want to do that, and you should, if you want to be lazy, you can use bind include. So you can say that I only ever want to bind to these properties on my model. Don't use bind.exclude, because I will tell you why. How many of you trust your coworkers? Yeah, no one. All right, so see, that's right. If you use bind.exclude and you say, okay, so I know which things in this class are unsafe to bind to, and your coworker comes along and adds a new field and you don't know about it and they haven't updated bind.exclude, well, then you're bind.screwed. So always use safe lists. Use include. Path traversal. How many of you are accepting uploads in your websites? Yeah, I'm going to make all of you unhappy. You don't ever believe the file name that comes through, of course. I'm not even going to ask. Even though that the RFC says that you should only ever get a file name that does not have paths, well, you can just ignore that and use something like Fiddler to send .. .. and the path name. So if you believe that, you're in a mess. How many of you who are accepting file uploads are accepting zips and unzipping them? Yay. So I have something for you guys to do. Against your development environment, not your live environment, I want you to go back, search the internet for 42.zip, turn off your antivirus, which I never recommend normally, and download it because it will upset your antivirus. What 42.zip is a 42K zip file, and because zip files are recursive, it expands into 4.5 petabytes of data. So you two that put your hands up really need to think about different ways to unzip. The way we do it in Azure and the way that we do it in NuGet is we have detonation chambers. We spin up VMs specifically for unzipping. We copy the zip file into it. We tell the VM to unzip it. And if it hasn't done it after 5 seconds, we just throw the damn thing away because it's just not trustable. Now, OK, you may laugh at those two that were accepting zip files. How many of you are accepting XML files? Because it has exactly the same problem. This is 10 entities, which are defined of 10 entities of the previous entity and so on and so forth. This, when you parse XML, will turn into 1 billion entities that contain LOL. This is preventable by turning off DTD parsing. So you should do that when you're parsing XML. So quickly going to run through, because I only have a couple more minutes. Now, like I said, I can't break as many things as I want because of back compatibility. And the same people that are on web forums probably have employers that would be upset if I broke things due to security. So with each version of the .NET framework, we add more security in and we fix stuff. But a lot of these things are what we call quirked, and you have to opt into using them. So for example, we added a bunch of stuff in .NET 4.5. But you have to move the framework that you are targeting to 4.5 to get them. And the same for 4.5.1, 4.5.2, and so on and so forth. So when we release a new framework, either update your targeting framework or change your compatibility mode. And that will opt you in to all the latest defenses that we have added, which includes string hash code randomization. Despite us saying in all our documentation that hash codes may be different from one run to the next, some people do not read our documentation, especially the things where we say, don't do this, it's dangerous. And so we can't turn that one on by default. But all of you should go back and turn on that runtime switch for the .NET framework. In .NET Core, because I could break things, because we were breaking the world with .NET Core, this is on by default, and you can't turn it off. So haha. Data protection. ASP.NET 4 had machine key.encode and machine key.decode, which were silly. They would actually allow you to do encryption without signing, which is why SharePoint got in such a state. So we've replaced those with machine key.protect and machine key.unprotect. So you should use those to round trip data to user space and validate it when it comes back. In .NET Core, we have a data protector which replaces everything. You don't have machine key anymore. You have a key ring that you can store in various places, be it SQL, be it this local file system, be it Redis, be it Azure Key Vault. I like Azure Key Vault for these things. How many of you have encountered partial trust in your websites? None of you. Oh, OK, I can skip over that. It doesn't work. We killed that 5 or 6 years ago. And again, no one reads the documentation. But what it was doing, it was supposed to remove certain types of permissions. So people would say, OK, I'm going to run this website in medium trust because I don't trust some of the code, and that's not going to be able to start a process or go wandering around the internet on its own. It is broken. It is not getting fixed. It is not in .NET Core. Request validation should be part of defense in depth. It should never be what you solely rely on. And again, we threw it away in .NET Core because it's kind of broken and we can't fix it. Excuse me. So I can show you breaking partial trust because this is funny. And hopefully it gets the point home, because I'm sure some of you know someone who does this. So here we have a good old web forms app, because they're really easy to demo with. And I'm going to do process.start and try and pop a command shell. And then I'm going to do it in another way. So partial trust is set up in your web.config. And here we go. Trust level is medium, and that should not allow me to start a process. So I can hit launch a shell, and I get a security exception from partial trust. If I go, yeah, no, do it, then we have problems. Partial trust was a great idea, however, it was implemented in the wrong place. Permissions should frankly be enforced by the operating system, which is why containers are good. All right, let's stop that. Okay, so I have one last demo. It's not bad enough that you can delete files via serialization. This demo is taken from a presentation at Black Hat this year, which is the security conference to go to, which is full of the great and unwashed. I'm not even kidding. It's literally unwashed people sometimes. You can find it on YouTube by searching for Friday the 13th JSON attacks. It even mentions JSON.net. The owner is nodding. I told you to remove that switch. But they did point out that, I will be fair, JSON.net is secure by default. You just have to set an option that basically says, I'm throwing caution to the wind, and if you do that, it's your own fault. So I warn you that this is not going to be pretty, okay? And because I've warned you, I do not want to see any red things in the bowl just because this demo has upset you. Okay, so normally what I do in a country that has decent internet is this talks to the internet. Cannot do that here. So I spent last night basically spending 15 minutes downloading a single image and then running it on a little host web server. So I'm going to start my little web server up. But, you know, in a country with decent internet, this would talk to an untrusted website. All this is doing is it's going to serve up some code. Nothing very exciting. All right, so we'll just minimize that. And then we have serialization exploit demo. Binary formatter is bad. In all seriousness, go through your code and look for instances of binary formatter and then rethink and regret your decisions, because I see this far too often. Binary formatter and JSON formatting, if you have turned on the really silly, unsafe option, what they do is they include information on what an object is and then the data. So, like I said with the temp file collection, I can say what type of object you're going to deserialize into. So here we have a payload file, and I have a file stream, and I'm basically just going to deserialize it. So let's debug this. Start new instance. So my web server is running. Look, no hands. PowerShell started. It's doing, oh my God, that's horrible. I tried to think of the most shocking and disgusting thing for an Australian audience, and it was either this or a link to the BBC article that proves that pavlova comes from New Zealand, which is apparently where you all stole flat whites from as well. Just stick to claiming that you invented lamingtons, because frankly, no one else wants to claim those. Okay, so binary formatter is bad. Trusting data that comes from an untrusted user is bad. Sign everything. Sign it with an authenticated signature and keep the key for that authenticated signature private. Don't publish it on GitHub. Okay. So And like I say, opt into all the new protections that we give you by changing your framework version every time that we release one. Don't use regular expressions. Don't opt out of all the protections that we give you by turning view state Mac off, because it makes me very unhappy. All right, so as you can see, this is a slide from, I think, TechEd. There is no microphone. We have 5 minutes for questions, which is better than normal, because I normally waffle on for an hour and a half, but I've actually kept time. Does anyone, apart from James, have a question? Hello, sir. Oh, there is a mic. Oh, my goodness. Thank you.
Just to clarify, when you're talking about keeping your signing keys secret, you're talking about sort of certificates. You're not talking about strong signing.
Okay, the question is, when I'm talking about signing keys, what am I actually talking about? Honestly, it's everything. In this case, I'm talking about signing keys for your checksums. So you use a message authentication code, and what that does is it checksums your data, but it also takes a key and it merges the two things together. Because if I just use a normal MD5 as a way of validating stuff, well, the attacker can calculate the MD5. There's no secret there. But if I use an HMAC, I have a key that feeds into that HMAC, so an attacker cannot reproduce the checksum because they don't know the key, unless you publish it on GitHub, which is roughly what machine key does in web forms. Also, yeah, you shouldn't, upload your certificates to GitHub. Certainly not with a private key. Strong naming is one of those security things that we've gone, yeah, this is not security anymore, and it is just used for identity. And if you will notice, if you look at the .NET Core repos, we actually publish our strong name keys because they're not for security, they're just for name resolution. So I honestly don't care if you upload those to GitHub. Does that answer your question? Does anyone else have a question? No. Okay, you're all too shocked by seeing England win the Ashes. All right, in that case, thank you very much, everybody. Remember, no red Post-it notes just because England won the Ashes a few times. I'm Irish, I honestly don't care. All I care about is the rugby, and I'm not gonna talk about Ireland versus anyone else in the rugby. Thank you very much for coming. I hope you have a great rest of your conference. If you want to see something that actually has proper technical content, I will be talking about security in ASP.NET Core 2 at some point on Friday, unless a drop bear gets me. Thank you very much.